Hi, everybody. Here I am on my way to the lake to get a load of sand in my trusty egg carton.
And here I come.
Okay, but remember, I'm going to do the talking. You better tell Mom you're going.
She knows.
While you're writing, you can think about what I'm going to talk about. Matter.
Matter?
You know, things all around us, like slides and kites and sidewalks and benches and rain that helps trees grow and air that kites fly on.
Those are funny things to think about. Why should anybody want to?
Because those things will help everybody think about the different states of matter.
States?
Sure. Think about wood. Wood is matter in the solid state. You see?
Solid. Oh, sure, I see.
And water. It's a liquid. Water is matter in the liquid state. And the air that's all around us, air is a gas. Air is matter in the gaseous state. I can't see it, but I can feel it when I wave my hand.
I can kind of feel it, too.
Okay. Now, since you know the three states of matter, solid, liquid, and gas, we can talk about some ways matter can change. You want to finish squashing this can?
Okay.
Do you know what this shows?
What?
That the size or shape of matter can be changed.
Is that what this shows?
Oh, be quiet and come on. I want to show everybody something else. You know what my sister's Drippy Popsicle shows? That the state of matter can change. Solids can change to liquids, and liquids can change to gases. And matter can change the other way, too. That's because matter is made of very small parts called...
Bloom!
No, molecules. A solid, like a rock, has a shape. A solid keeps its shape and size unless something changes it. Solid things have shapes. That's because in a solid, the molecules are very close together and don't move around very much. Something like this. When molecules are very close, they have a strong attraction for each other.
You mean they hold on to each other?
Kind of. And that means that a solid keeps its shape unless something changes it. But molecules in a liquid don't attract each other as much. So a liquid takes the shape of whatever it's in. Liquids take the shape of their container.
Oh.
In a liquid, molecules have more energy than they do in a solid, and they go faster, too. They bump and move around a lot. They spread out to the sides of their container and settle to the bottom, too. And gravity gives the liquid a smooth top surface. But even though liquids don't have a certain shape, they do take up a certain amount of space. A little water will fill a little space, and a lot of water will fill a lot of space.
What's so unusual about that?
Well, that isn't the way it is with a gas. When you blow into a balloon, you're blowing air in. Air is a gas. As soon as you blow any air in, molecules of air go everywhere in the balloon. Well, that's the way it is with all gases. Gases fill up whatever they're in.
How come?
Let me let go of the balloon first, and then I'll show you. Okay, it's because of molecules again. Molecules in a gas have lots of energy. They move in all directions until they bump into something, and then they bounce off. That's how they fill the whole container they're in. Even when you let some gas out of a container, the molecules that are left in still fill it. You think the balloon will be empty soon?
Won't it be?
Nope. It'll still be full of molecules of air. And because gas molecules have so much empty space between them, we usually can't see gases.
Is that why air is invisible?
That's why.
That's very interesting. You sure know a lot about matter. I especially like the part where a solid changes into a liquid.
Oh, you little... Oh, you made me forget my egg carton. Wait till I catch you.
While my daughters are busy chasing each other, I'm going to make a physical change in a piece of wood. A change in size is a physical change in matter. The molecules of the wood aren't changing. I'm just sort of chewing some of them out with a saw to separate the board into two pieces. Molecules in a solid attract each other, so it takes energy to saw through wood. But it takes even more energy to saw through metal. The parts of a metal are attracted to each other even more strongly. The kind of energy I'm using to do this work is called mechanical energy. I have to use enough energy to overcome the force that holds the metal together. And I did.
The physical change I'm going to cause will make something get bigger instead of smaller, and I'll use a different kind of energy to do it than the girl's father did. This is something I usually do for my science classes. It's a good demonstration. See how easily the metal ball falls through the ring? Of course, that's because the ring is bigger than the ball. But I'm going to change that. It's not a trick. I'll do it simply by using heat energy. I'm going to make a physical change in the ball. The flame heats the metal ball. When the metal is heated, what do you think will happen? The ball became too large to go through the ring. Heat makes metal expand. Heat makes most substances expand. That's another physical change. And that's the end of my part of the story for now.
Do you think you can behave?
I'll try.
Because there's something else I want to show you about how heat makes metal expand and causes physical change.
I can't hear you.
I said I want to tell something else about heat making metal expand.
What's that?
Sometimes things are built so that they can expand without causing any problems.
Like what kind of things?
Like railroad tracks, for instance. They're made of long pieces of metal, you know. Do you think the pieces are put right up against each other?
No.
That's right. See? There's a space between the rails so they can expand when they get hot.
That's cool.
I'm back again, and I'm going to show you another kind of physical change that happens to things when they get hot. This is a piece of solid lead that I'm heating. Do you know why the lead is dripping where it's being heated? It's dripping because it's melting. It's changing to a liquid. The lead is changing state, from the solid state to the liquid state. Change of state is another kind of physical change. The liquid lead is dropping into a dish. But do you think the dish is filling up with liquid lead? No, the liquid lead is cooling and changing back to solid lead. If you make most solids hot enough, they'll turn to liquids. If you cool them enough, they'll change to solids. And if you think that's interesting, I've got something else to show you. This will help you understand why changes in state take place. These things aren't hot, they're very cold. We call this dry ice. But these are really chunks of solid carbon dioxide. Carbon dioxide is usually a gas, but when it's cold enough, it's a solid. Now I'm pouring in some alcohol. The alcohol will get very cold, much colder than water when it freezes. Now I'm floating an ice tray in the alcohol, and I'm going to pour some water into the ice tray. Can you guess what's going to happen to the water? If you think it's going to freeze, you're right. That'll take a little time. But lucky you, you're going to get to see it happen in speeded up motion. Ready? The water's freezing. Do you know why cold does that to water? Because as the water cools off, its molecules slow down, attract each other more, and arrange themselves in certain positions. A change of state takes place. Liquid water becomes solid ice.
When water boils, its molecules move so fast, it changes to a gas.
I see it. What's that ice cube tray for?
That'll help me tell you about water in the gaseous state. Water vapor. The bottom of the tray is getting wet.
But where's the water coming from?
From the water vapor. The cold ice cube tray cools the water vapor and changes it to tiny drops of liquid water. The air cooled the hot water vapor and it changed state. Now I want to talk about another kind of physical change. Suppose some lemonade I make tastes too sour. What should I do about it?
Oh, you know, put sugar in it.
Oh, you're so smart.
But where's the physical change?
Just wait a minute till I get the sugar. Now, the physical change I'm talking about happens when some solids are mixed with some liquids. like when sugar is mixed with lemonade. Let me put in some sugar and we'll see what happens. The solid sugar seems to disappear into the liquid. It dissolves. Dissolving is a physical change. The molecules of the sugar fit in among the molecules of the lemonade, which is mainly water. When a solid is dissolved in a liquid, we call it a solution.
Is your solution sweet enough?
I'll see. Yes, it is. Now, you can make a solid come out of a solution by letting the liquid it's in change to a gas. You can let the liquid evaporate or heat it to speed up the evaporation. And then you get the sugar back. Some of that's sugar on the inside of the glass.
Physical changes like the one you just saw are used to get the salt out of salty seawater and turn it into fresh water. That's what I'm doing here. I'm boiling seawater with salt dissolved in it. The heat changes the liquid water into water vapor, but there isn't enough heat to do anything to the salt that's dissolved in the water. The salt stays behind. The hot water vapor cools when it goes into the glass tubes and changes state. It becomes a liquid, water without salt, fresh water. And when all that water has evaporated, what do you think will be left? No more solution, just salt. With the water gone, the salt that was dissolved is solid salt again. And it doesn't look like salt, but it is. People can use salt from seawater. Sea salt is just seawater without the water.
Now, I'll use the sand I got at the beach.
What are you making with the sand?
I already made 'em. Molds for candles.
You're making candles?
Yep, with the help of physical changes, of course.
Come on.
Really? See, I'm shaving off pieces from big chunks of wax. Remember, a change in shape is a physical change.
Oh, sure, that's right.
And the next thing I'm going to do is a physical change, too.
It is?
Sure. I'm going to melt the shavings. When solid wax changes to liquid wax, that's a physical change.
Hey, I can smell the hot wax.
Sure. A little changes into a gas that fills the room. That's what you smell. And now, the liquid wax will take the shape of the mold I made. See?
I see.
And when the liquid wax cools and it changes to a solid, it'll keep its shape, like this one did. Isn't that neat?
It sure is.
Physical changes are really useful.
They sure are.
Now, I'll review what they are.
Let me do it.
Sure, go ahead.
Well, physical changes are changes in size or shape or the state of things, or when things dissolve and make solutions, or come out of solutions. Right?
Right. You're a smart little sister.
You're not so bad for a big sister either.
Haven't I always told you that?